I'm done.
Alright, so today we're going to define and graph exponential functions. Are you guys ready?
No.
In the middle, I want you to write exponential function.
I was watching this movie last time. Was that great?
Was it called your math class right now?
Yes.
Good, let's do this.
Okay.
Exponential function. Now, what do we know about exponential functions from our work yesterday and Tuesday?
They have to be related.
Nada? They do have to have exponents, yeah.
They have to be
What else do we know? Girls, since y'all are talking over there, why don't you tell me what else we know about exponential functions?
The lines are curved.
The line is curved. Good. What's another thing? Damien?
It increases drastically.
Was that what you were going to say? It does. Okay, but there's one other thing that we learned. We wrote an equation for it, and what did it have as the exponent? It didn't have chips. Nope.
What'd you say?
What did it have as an exponent?
0.
No, I told you no when you said that 3 times.
One.
No.
Two.
No.
One.
Why do you keep saying it when I keep saying no? No. It's not a number.
I don't know what y'all call
Yes, X. X. Good. Alright, so you said 2.
You got the best game.
So the definition is, it says, an exponential function is a function with an exponent. Whatever that is, make it stop. Who is humming? Stop humming. It has an exponent of x. Oh my gosh. I don't know why you think you can sleep through this lesson, but everyone else is writing, so you should be writing.
Who's sleep?
You. Alright, now, we have some very specific characteristics. Who remembers the 2 types that we talked about? One starts with a G, one starts with a D. Bryn.
Geometric.
Decay and growth. Good. Both of you take a point. Geometric.
I was thinking about sculpture.
Alright, so it looks like this. We would say f at x equals a times b to the x power. Now, a is usually 1, but it changes our function. This is our starting value. And it changes our function. It tells us where we start at. If it was a 3 times the exponential function, then we would start at a different place. Does everybody understand so far? Now, if it's a growth, what does b have to be?
Whoa, Bryn, what are you doing here?
She's excited because she was in here last period, half listening. Half listening. All right. So B. Alright, so if B is greater than 1, it's a growth. Yes, that's what that symbol is. Hey, Diamond, do you need to bring me that? Are you sure? Because it's red day, so it shouldn't even be out. And you're not special just because you're on the other side of the room and you think I can't see you, because I can. So put it away. Away. Alright, now, if it's a decay, it has to be between 0 and 1. So what numbers are between 0 and 1?
0.5?
Yes, 0.5. And, yes, 1/2 is 0.5, right? What about 1/3? What about 1/4? What about 1/6?
Oh, yeah.
What about 1/25?
Oh, yeah.
What about 3?
Oh, yeah.
3? No, 3 is not between 0 and 1.
You got me off track. 10. You played yourself. I played yourself.
Alright, so those are our characteristics. Now we're going to talk about some examples. Hey, Jacoby, again, we're not sleeping through class. Okay. We're not sleeping through class. But if I have to tell you again, you're going to have to stand up the whole time. I'm sorry? Okay, then stay awake. No, Pumpkin. You don't get to tell me what happens in my class. Alright, so an example would look like y equals 3 to the x power. Why is this an exponential function? The x is the exponent. What about y equals 1/3 to the x?
Still.
It still has an X, so it's gonna be an X.
Fantastic. What about this graph right here? Is this an exponential function?
Yes.
Is that a growth or a decay?
Decay.
It's a growth because it's getting bigger. See how it's going up? Always start from the left on your graph. So you start from the left. If it goes up, it's a growth. If it goes down, it would be a
Decay.
decay. Is someone banging on the door?
Who is Justin? Kelly.
I was going to use
Hey,
people way
Justin.
to text me.
Oh, you make voice videos.
Okay. We're having class. So, non-examples. Non-examples would be something that's not an exponential function.
It's straight.
It's a straight line, which would be like 2 times x, correct? Or you could say x squared. Neither of those are exponential functions. A graph that is not an exponential function, like Natalie said, could be a straight line. And Brennan said it could be a wavy line. Like this. That is not an exponential function.
Well, we see that.
It's on the 12th. Yesterday was the 12th. What, Natalie?
We see that on the test.
Maybe. Maybe not. What we are going to do today, though, is we're going to practice graphing the different types, and then you're going to do it on your own. And Monday we're going to play a card game to match them up.
Oh, a card game?
Yep.
Let's play poker.
No. Are you ready? We're going to... No.
Let's play blackjack.
No. All right, turn the page to 14B. 14B.
Right.
14B. All right, so what we're going to write first is we're going to write the 4 steps on how to graph. And then we're going to graph 3 growths and 3 decay. It's easy. Easy.
Do we have to find the points that we graph on to?
Well, that's how we graph. Yep.
No, I mean, like, are you going to make us work out to find the, what are they called? The 2 numbers?
The coordinates?
Yeah.
Yes, that's how we graph. So the first thing we do is we create an X, Y table. Do you guys remember what those look like?
Isn't it?
What do they look like?
Isn't it?
So you don't remember? This is an XY table? Yeah. Yeah. And you have to pick your X values. So we're going to pick -1, 0, 1, and 2. Sometimes we'll pick -2. Sometimes we'll go crazy and do everything. Number 2, the step 2 is you use x to find y. So what do we do with our x values to get our y values besides Bryn? What have we done every time?
I just feel like a Thursday.
I don't know, but we've been doing this for a year and a half now. So you take your x and you plug it in to get y. We've been graphing for a long time. Alright, step 3. What would you do after you find your coordinates? You have to do something first before you connect the dots. You plot the points. Plot the points. And what do you think the last thing is that we do? Graph it. Sketch your graph. Dun, 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 and then you're done. Are we ready? Okay. Bum, 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 bum. Are we ready now? How about now? Okay, so let's start with example 1. I want you to graph f at x equals 2 to the x power. I just want you to write that down, and then we're going to do it together. Are we ready? Oh my gosh. It's one word and 3 letters and a number. Oh. Okay, so what I want you to do, create. ¿Por qué no? ¿Por qué no? Oh my gosh, y'all need to hurry up. Ever. No. What are you gonna do? Get upset? What words was that? No. Okay. I can hear you perfectly. Your volume is not the issue. It's enunciating, which we've talked about for a year. All right, -1, 0, 1, and 2. I want you to use those every time. Now, what we're going to do in the middle is we're going to write down our process. So we're actually going to write that we plug in 2 to whatever power. Does everybody understand?
Yeah.
And Eric's going to stop getting on his phone. Ever's going to stop making those faces. You can't see which part?
Why don't you just break?
All right, so everybody write 2, 2, 2, 2 in the middle. And then I want you to write -1, 0, 1, and 2. Now, does anybody remember what we do with negative exponents? Nope. When we have it,
You put them on the bottom.
you put it on the bottom. You flip it. So 2 would become what? 1/2. 2 has an invisible 1 with it. So if you flip 2 over, it becomes 1/2. We don't have to write the 1 underneath it, but it does. Does everybody understand what it did?
Yeah.
Are we sure?
Yeah.
Okay. Now, what is anything to the 0 power? Not Bryn.
1.
Not Bryn.
1.
1.
Okay. What's 2 to the first power? 2. And what's 2 squared?
4.
Fantastic. Now, our first step we had to do was create an XY table. Did we do that? Fantastic. Our second step was use X to find Y. Did we do that? Have we plotted our points yet?
No.
Let's do that. Now, this is what your graph is going to look like. No. Draw your graph that looks like this. Do you need a blanket? All right, so now we need to plot. Is everybody ready where I start plotting? Okay. No, before I start speaking real fast. This is why we have to hurry, because when we pause, people start talking about things that don't matter across the classroom. All right, -1 and 1/2. So you would go left 1, and then I want you to go up halfway. -1, and then 1/2. Okay. All right, now 0, 1 would be where? Up 1. All right, what about 1, 2?
You go up 1, right 2.
Go right 1,
Up 2.
right 1, up 2.
I said that.
And then 2, 4.
Right, up 4.
And then what do we do?
You gotta do the line.
You got to do the thing.
Yeah.
You got to sketch the graph.
What you know what I mean?
Now, it does not cross the x-axis, so do not cross the x-axis. It'll just keep getting smaller and smaller and smaller. And then we're done.
Small.
That is a growth. Why is it a growth?
Because it's going up.
Yes.
Increases.
Now, can you tell from here if it's a growth or not?
No.
Yes, you can. We just wrote that down. We wrote down that if b is greater than 1, it's a growth. Is this greater than 1? It's a growth. All right, next one. Do you want to try this one without me or one more together?
One without few.
Okay. All right, so please graph f at x equals 3 to the x power. When you're done with your table, let me come check it before you graph. All right, so hopefully you made your table, and it looks like this. All right, you have x, 3 to the x, and y, correct? And then for your x, you wrote down -1, 0, 1, and 2, correct?
Yes.
All right, and then you wrote all of your 3's.
Yeah.
And then -1, 0, 1, and 2. All right, now, 3 to the -1. It's a negative exponent, so what do? You flip it. It has an invisible 1, so this becomes positive 1/3. Okay? 3 to the 0 power is 1. 3 to the first power is 3 squared is. Can you guys graph it without me? Yes, you can. You got it right? Did you graph too?
Yes.
Awesome. I didn't see your graph. Why are you rolling your eyeballs at me? Oh, I did. I'm sorry. I got confused. How did you guys plot -1 and a third?
Left 1 and halfway up.
And you go up a baby bit, correct? All right, what about 0, 1?
Go right 1. I mean, up 1. Sorry.
What about 1, 3?
Go right 1, up 3.
What about 2, 9?
Go up.
Right
Okay, right 2,
2,
up 9. And then you got to draw your feet.
It is a growth. Why do you know it's a growth?
It goes
You gotta
higher.
read it left to right.
Because it goes up. And because this number is
Hey.
greater than 1.
Yeah.
Okay, so now let's go crazy. Are you guys ready?
No.
No. No. All right, 14C. Let's do this. We're gonna throw a fraction in. It's really easy.
Hello.
It really is. You just flip it.
That's the way. That's my way.
All right, so example 3. I want you to graph y equals 1/3 to the x power. Do you think this is going to be a growth or a decay?
I think it's gonna be a decay.
I think it's going to be a decay as well, my friend.
I like it a lot.
It's fine.
Okay. All right, weirdos. Calm down.
Did you just call us weird?
No, never.
She called a lie. You call.
All right, so -1, 0, 1, 2. What do we write in the middle?
1/3.
We write our operation, correct? And then it's going to be to the -1, to the 0, to the 1, to the 2. Now, anytime we have a negative exponent, what? Do I need to give y'all a second? Okay, I'll pause. I'm sorry, I get excited. I love graphing. You know that.
Chill out. Someone's had a couple sodas. It's full of energy.
Yeah. Okay. Are we ready now?
Almost.
Okay.
Oh, that grease.
Easy. Easy.
Okay, I'm ready.
All right, are you ready now? Okay, so anything to the negative exponent, what do we do? And if we have 1/3, what would we do with that? Flip it, and it would become 3 divided by 1. Now, do we write the 1?
No.
So what's our answer? 3. Okay, now what's anything to the 0 power? 1. What's 1/3 to the first power? 1/3. Okay, now, here's where it gets difficult but shouldn't be, and I don't know why we're confused. It's 1/3 times 1/3. Okay? So what's 1 times 1? What's 3 times 3? So it's 1/9. That's it. That's all you do.
Totally not confusing at all.
I know. Let's graph it. Reggie, are you being hateful?
No, only I say when he's like, it's not confusing at all. I thought he was being sarcastic.
It did sound a little
Yeah,
sarcastic.
That's how I was like.
Were you being sarcastic or serious?
Serious.
Okay. He's got that me tone to his voice, doesn't he? Where you're not quite sure what's happening. All right, so let's. Ooh, I'll give you a second. I'll pause.
Okay, you gonna go?
If you're ready, graph.
Okay.
If you're not,
No, if you're not, hustle. All right, so where's -1/3?
there you go.
Where's -1/3? Paris, since you are just so bent on talking, can you tell me how to get to -1/3?
Go left, go left, go left.
What?
Go left. Oh, I gotta go there.
No, I just want you to tell me what you're. I want you to use like real words.
Go left. And go
Go left. How many?
one.
And then
Go up there.
good.
And then go up one right here. And then go one.
You said
Right
go
one.
one.
And then go fairly up just a little. And go to 2. And go up just a little. And then it's a decay.
And then it is a decay. Why is it a decay, y'all?
Because it's going down.
Because it's still going down, and this number is, so it is a decay. Now, just because it's a fraction, does that make it a decay?
No.
It has to be less than 1, right? So we need to be careful. Can you practice one without me?
No.
Yes.
No.
You can.
No.
No.
Well, you're going to. Look at that.
Well.
Ready? Example 4. Did you ask what time it is? Because there's a clock right there.
Yeah, but it's fine.
The numbers didn't change just because I put stickers over it. Fun fact about that. The clock stayed the same. It is. Because then you're practicing your perfect squares, aren't you?
Did you know when I first read this, did you know that was up there?
I did, and y'all didn't even look.
I looked the whole time.
Good. Proud of you.
And then I told Mackenzie when she's not here.
1/4 to the X power.
Not think of that.
Ma'am? I'm going to show you. Alright, 8 notches down. Alright, 1/4 to the X. So you have -1, 0, 1, and 2, correct?
Yeah.
And then you have 1/4 to the -1, 1/4 to the 0, 1/4 to the 1, 1/4 squared, correct? So then, when you have a negative exponent, what do? And that gives you 4. Anything to the 0 power is? 1/4 to the first power? 1/4 squared? Alright, now, to graph it,
How can you do it?
label your X and your Y each time. She can hear you. I'm right here. But if you want to keep talking about me, feel free to try.
Oh my gosh. How you gonna talk about
Alright, -1 to the 1, 2, 3, 4. 0, 1. Now 1 and a 4th, you just go right 1 and then up a baby bit. 2 to the 1/16th, you go right 2 and up a baby bit more. Homework.
Not me.
So yeah. See.
Not me. I'm so glad you did homework.
I'm sorry.
Done. I was talking about that. 375.
3.
Oh, okay. I thought you were about to say a little big number like you always do.
3 problems. I want you to graph
Can I put it on the back portion of YouTube?
4 to the X. 1/5 to the X. 2 to the X plus 2.